What if I told you I don't want to block a PC on my network, but I want to block a specific service? That's something a standard ACL can't do. In this video, I'll break down what an extended ACL is, how they actually filter traffic, and then we'll configure one step by step on a Cisco switch using 2 VLANs and 2 PCs. So just a quick recap if you didn't watch the last video, ACLs or access control lists are rules that permit or deny traffic. You can think of an ACL like a security guard at the door. They're the ones who allow people to get in or block people from getting in. There's two main types of ACLs, standard ACLs and extended ACLs. I covered standard ACLs in the previous video, and we learned that standard ACLs only look at the source IP address. Today, we're going to be looking at extended ACLs. So it's like the better version, and they give us a lot more control. So ACLs are processed from the top to the bottom. So it's going to look at the first rule, and then the second rule, and then the third rule. And once there's a match, it ignores all the following rules and uses that rule and applies it. If a packet doesn't match any of the rules, there's an implicit deny at the end that'll just deny that packet. This means that every ACL, extended or standard, will end with a deny any entry at the end of the ACL. So if you forget to permit something, it'll be blocked. This is why people will usually put a permit any entry at the end so that they can negate the implicit deny at the end. So what is an extended ACL? An extended ACL can filter traffic based on the source IP address, the destination IP address, the protocol, and the port number. So compared to standard ACLs, extended ACLs are a lot more specific, and that's why they're used a lot more in real networks. I actually don't even know why someone would use a standard ACL in a real network. So just like standard ACLs, extended ACLs also have two types, numbered extended ACLs and named extended ACLs. If you're using a numbered extended ACL, the range is from 100 to 199 and 2000 to 2699. You have to use a number from those ranges to indicate that this is an extended ACL. Or you could use a named one, which is a lot easier to do and a lot better in my opinion. You don't have to pick a number from those ranges to indicate that it's an extended ACL. You can just type extended and then pick a name for that ACL. When we get to the lab part, I'm going to use the named extended ACL because it's just better. And that's what you'll really want in real life. So let's take a look at Packet Tracer to get a high level overview of the topology we'll be configuring today. Okay, so this is the topology that we're going to be looking at today. We have two PCs, my Windows laptop and my MacBook. They're both going to be in different VLANs, VLAN 10 and VLAN 20. And they're going to be connected by a layer 3 switch. And this switch is going to have IP routing enabled. I'm going to have two SVIs, one for VLAN 10, one for VLAN 20. The Windows laptop will be able to ping my MacBook, and the MacBook will be able to ping my Windows laptop across the different VLANs. And by default, the Windows laptop will be able to SSH into the MacBook. But what if we want to disable that feature? We don't want the Windows laptop to be able to SSH into the MacBook. How can we do that? We can't do that with a regular standard ACL. So we have to use an extended ACL. We'll configure it to permit ICMP traffic, so to permit pings from my Windows laptop to the MacBook, but to deny SSH traffic from my Windows laptop to the MacBook. So we're not blocking the Windows laptop as a whole, we're blocking a specific type of traffic from that Windows laptop. And this is exactly what extended ACLs are used for. And one big thing to note for the CCNA and just to know in general, if you remember from the previous video, I mentioned that standard ACLs have to be placed as close to the destination as possible because since you're only filtering traffic based on the source IP address, you don't want to mistakenly block traffic. If you put it too close to the source, it'll just block traffic even though it's not going to the destination that it's supposed to be blocked for. But with extended ACLs, since we can be as specific as we want, since we can configure the source IP and the destination IP, we have to put it as close to the source as possible because you want to stop unwanted traffic as early as possible. And you don't want to waste routing, like you don't want to waste resources if it's just going to be blocked at the end anyways. Imagine you have like 50 routers on the way to your destination, it routes through all of them, and in the end, it's just going to get blocked anyways. It's just a waste. So in our topology, the source, the closest place we can put our ACL is VLAN 10 interface. So we're going to apply the ACL inbound onto VLAN 10 interface. So now let's actually configure this on the real switch. So first let's use this console cable to connect our laptop to the switch so we can configure it. Okay, so let's take this end and let's put it into the console. Sorry, you guys are upside down, but... And then let's put the USB side to our laptop. So now that we have that connected, let's connect our two PCs via Ethernet. So now that we're connected to the switch, let's go to Device Manager and see what what COM port we have to connect to. COM5. Every single time I've done this, it's been COM5, so I don't even know if it changes. COM5, we're gonna leave the speed as is and press open. So I've already configured the switch to have VLAN 10 and VLAN 20. I've already configured the SVIs. So now my Windows laptop should be able to ping the MacBook. Let's just test that out. Ping 192.168.20.2. All right, it's able to ping the MacBook. And now let's try to SSH into my MacBook. SSH Paulo Reyes at 192.168.20.2. It's asked for a password. And there. This is my MacBook. It literally says. So I'm SSH'd into my MacBook. You can see here that VLAN 10 is assigned to G0 or port 1, and VLAN 20 is assigned to port 2. And we can look at the SVIs, do show IP int brief. You can see that VLAN 10 has an IP address of 192.168.10.1, and VLAN 20 has an IP address of 192.168.20.1. So this is just like the packet tracer topology I showed you guys earlier. So how do we configure these extended ACLs? It's pretty much the same as standard ACLs. You do IP, access list, extended, and then the name. So we'll name this no SSH. And now you're in the access list config mode or whatever it's called. Now let's review what we want to do. We want to prevent our Windows laptop from being able to SSH into the MacBook, but we should be able to ping and all other traffic should go through, just not SSH. So first we use the command permit. So after we type permit, we type the protocol. So if we press question mark here, there's a lot of different protocols that we can configure the access list to permit or deny. Some notable ones, you're going to see IP, which is any internet protocol. You have TCP, UDP, and ICMP. Those are really the four main ones that you need to know for the CCNA. So let's permit ICMP. So this permit ICMP traffic coming from 192.168.10.0. So this is VLAN 10's network, and the destination is 192.168.20.0, 205.205.205.0. So this is telling the switch, if there's an ICMP packet that comes from VLAN 10's network and the destination is VLAN 20's network, permit it. So just let it go. The second entry we're gonna put is the deny statement. We want to block SSH traffic coming from VLAN 10's network to VLAN 20. We do deny, we do question mark again, and SSH is a TCP protocol, or SSH uses TCP. So we do TCP, and then the source, which is 192.168.10.0, 255.255.255.0. The destination, 192.168.20.0, 255.255.255.0. Now this is the really cool part about extended ACLs. You can actually specify the port number. So far, this entry is saying deny TCP traffic when the source is in VLAN's 10 network and the destination is VLAN 20's network. But this is denying all TCP traffic. What if we don't want to deny all TCP traffic? We just want to deny SSH. So we can do equals 22 because SSH is TCP port 22. So now this access control entry is saying block TCP traffic if the source is from VLAN 10 and the destination is in VLAN 20 and the destination port number is equal to 22. And then let's do permit IP any. This is just to stop the implicit deny from happening. And these three access control entries are all we need. So the last thing we need to do, we need to apply this ACL to an interface. So what interface are we going to apply to? We're going to apply it to VLAN 10's interface. Int VLAN 10. Oh shoot. Whoa, no. Int VLAN 10. IP access group, group, no SSH, in. And that should be everything. So now let's try pinging our MacBook again. So ping 192.168.20.2. It should be able to ping. Come on, bro. It should be, okay, there we go. Okay, it's able to ping. Now let's try to SSH into my laptop. Or now let's try to SSH into my MacBook and see what happens. SSH Paulo Reyes at 2.168.20.2. Okay, it's asking for a password. Okay, that's not supposed to happen. Why am I able to SSH into this? Okay, so I'm actually trolling. This is not supposed to have, this is supposed to be a wildcard mask actually, not a subnet mask. Bro, okay. All right, so now we have it down. That was a huge, okay, don't do that. Remember it's wildcard. Remember it's wildcard, okay? So we just have the exact same ACL, except it's with wildcard now, so it's gonna work. So let's try pinging. This should work. Please work. Okay, there we go. It works. And now SSH shouldn't work. It should take a bit of time, but it should say something like it's not allowed. It says SSH connect to host 192.168.20.2 port 22 connection timed out. And now let's show access list no SSH again. And look at this. This deny statement has 5 matches. So that means, I don't know, my Windows laptop sent 5 SSH packets and it blocked them all. I don't know why it doesn't say 3 matches for permit ICMP. It should say that it permitted traffic here. So yeah, that's extended ACLs. They're so much better than standard ACLs. I don't know why you would use a standard ACL in real life, but maybe there's some niche use case for them. But yeah, that's everything. It's pretty simple. There's a lot you can do with these. This is just one example of something that you can do with them, but there's a lot of things you can do with them. If you want to see how to configure a DHCP server, you can click the video that's on the screen right now and keep letting me know what you guys want to see in the comments, and I'll see you guys next time.